As we started this one, I was told to replace tangent of 2x with what it was on your formula sheet. That's a great idea. And then we do have to take it times this tangent, though, which would be over 1 plus 2 that's just kind of hanging out all by itself equals, so what about that tangent of 2x? Can we replace that one too? Is it the same thing? Oh, okay. All divided by tangent of x. So the main reason for wanting to do something like this is now every single one of our angles in this problem is x. And the example I used earlier is what if x was 10? Well, now I'm at least taking tangent of the same angle each time. Correct? Okay. Good start. But then somebody said, doesn't that make it worse? And well, let's look at what we have. Yes. But at least the angles are all the same now. Is this the only way to do it? No. Okay, so we're looking at the left side. You mean the first one in blue here and then the first green? Can we combine those? Yeah. Okay, well, so can we actually multiply this tangent times that tangent now? Because it's x and could we multiply them up here when it was 2x and just 1x? No, we couldn't. But now we can. Hey, this is helping already. 2 tangent squared of x. Do you agree with that? Are we good with that? Yes? No? Maybe? All right. Over 1 minus tangent squared of x. Now, one of you is probably going to suggest that we cross off the tangent squared x, and I'm going to stop you before you say that, because the bottom has 1 minus tangent squared, so they can't cancel. It'd be great if they could. We'd have 2. Right? But, no, that doesn't work. Yeah, the plus 2, believe it or not, the plus 2 pricing like the easiest part of this equation when you first looked at it, it's the one causing the most trouble. A plus 2 just hanging out, not really doing anything, is really causing a problem here. Any ideas of what to do with that stuff on the right? There's just fractions all over the place over there. Yes? It does not, well, it does, but can you show me how? You got to flip it up. So now here's where multiplying by cotangent actually helps, because it's the same angle, and that's what Tabitha told us to do earlier, but it wasn't making sense with the 2x, but now it makes a whole lot of sense with what we have now, because Danny is saying she thinks they now cancel. And does the tangent on the top and the tangent on the bottom actually cancel now? Yeah. Okay, so we're cleaning things up actually pretty quick. Here's where I kind of left the other class, kind of keep giving me suggestions, and then somebody finally gave me what is probably not what I would have done, but was an excellent suggestion. Let's face it, there are a lot of 2's in this problem, and a lot of tangent squareds. Any suggestions? Again, this is more to see what you can do. Yes?
Can you minus the 2 over the other side? Is that, can we write it as 2 over 1? So it's the 2 would be on top, and then that'd be 0 over 1, so you can do 1 big.
Well, the problem with moving the 2 is that you just move the problem to the other side. And we still would need a common denominator to do anything with it with that suggestion. Yes? The bottoms cancel, not quite. Not quite, but a good idea. Go ahead. Okay.
Oh, wait.
I think one of you just looked for a Pythagorean identity, and it's not quite. It's 1 plus tangent squared, not 1 minus tangent squared. That would have been a good idea. We have fractions, and we have that plus 2. Just really not fitting the whole mold here. If that plus 2 could be removed somehow legally, or at least look like the rest of this stuff, it would probably be very helpful. You can put it over 1 if you'd like. We still can't really combine it with anything, though. Once again, notice, is the trig really what's causing the problem anymore? No, it's the algebra. That little, yeah, if we could just erase that 2 that's sitting there, that'd be great. Yeah, you can minus it. Or if you have fractions in the problem, you could at least make it feel part of the group and get a common, at least then it'll feel like part of the group.
Yeah, so if you get a common denominator...
Can you combine it with things if you get a common denominator?
Yeah, you can. So,
Yeah.
wait, wouldn't you have to, if you get a common denominator, wouldn't you have to times it 2 by 1 minus tangent squared x?
Yeah, we unfortunately, to get a common denominator, we do have to multiply top and bottom by what the denominator is, which is 1 minus tangent squared, which is a slight problem, but let's see what happens. So I'm running out of room, so I'm just going to put my little plus 2 right here. 1 minus tangent squared. Well, the 2 really wasn't feeling like part of the group. You know, not that anybody in here can relate to that. I didn't say a thing. So basically, we should have the bottoms are now technically going to be the same, correct? Are they pretty? No. And I'm going to give you a second on your own. All right, I believe some of you have kind of figured out what's going on here, and then I will come back to a statement somebody made just a little while ago. It is something we did in Algebra 2, or actually earlier this year when we got everything with common denominators. It's something that we did. But really, if we look at the left side now, we have this 2 tangent squared just kind of still sitting there, right? And then I have plus 2 times all of this stuff, right? Can we distribute the 2 then? Yeah, so it's 2 times 1, which is, so plus 2, and then close, minus 2 tangent squared. And what does it say on the other side? It says 2. And then some of you at this point, I think, had the little aha moment. And I will give you a second to write that down. Does everybody understand where those numbers came from and all that information came from? Because before I took the break, I told you, or actually just right after I took the break, I told you that you were much closer than you probably thought you were. Because what can now happen with this numerator right here?
Oh yeah, cancel.
2 tangent squared minus 2 tangent squared cancels, and you are left with 2 over 1 minus tangent squared. Yes? Sure, most definitely. The question there was, and this goes back to kind of one of the things we did in Algebra 2 and earlier this year, is when we got the common denominators the same, we basically multiplied by the denominator. In other words, getting rid of it. And getting rid of fractions easier. And then what was asked is, what if I subtracted the 2 over to the other side and have 0 equals 0? Was there any step of algebra there that was incorrect?
No.
No, that's fine. All right. It all depends on how you wanted to do it. Once again, think to yourself and be honest with yourself. Is it really the trigonometry causing the problem? Because when I got here, I kept mentioning that 2 is just sitting there by itself. Well, then make it part of the group. Make it similar to everything else. And isn't that basically what we did here? We tried to get stuff to be similar to everything else. And that stuff kind of canceled off all by itself without even trying. Okay?